Here's the second problem off of Objective 3, Practice Test C, Stoichiometry. It reads, bismuth 3 oxide and zinc metal will react in the presence of extreme heat. We will write the balanced equation, and it's telling us the pattern of change, single replacement reaction. Bismuth is Bi, and the Roman numeral is telling me it's a +3. Oxide symbol is O, it carries a charge of -2, and when I crisscross, Bi2O3 is our formula for bismuth 3 oxide. Reacting with zinc metal in the presence of extreme heat. I'll place the triangle over the arrow to represent the heat. Now, the pattern of change says when a metal is active enough, it may displace the other metal from the compound. Zinc will displace the bismuth in our single replacement reaction. So now the element by itself is bismuth, and zinc will hook to oxide, and based on charge, we get Zn, who's a +2, O is a -2, we get ZnO. We'll need to balance. On the left, I'm counting 2 bismuth, so I'll place a 2 in front of my product, Bi. There are 3 oxygens on the left, so I'll need to place a 3 in front of our product, ZnO, and then backing up to repair the zinc. A 1:3 to 2:3 stoichiometric ratio. This equation will be used to answer letter B. How many atoms of bismuth? So our target product is the Bi. How many atoms of bismuth can be made when we start with 195 grams of bismuth oxide, Bi2O3, and 129 grams of zinc? Since we're given information about both reactants and the target product of the bismuth, we know it's a limiting reagent problem. I'll get my 3 steps of stoichiometry set, knowing that we're targeting atoms of bismuth. Same journey for this guy. Step 1, step 2, step 3. We want to get to atoms of bismuth and compare those to find the smaller of our 2 answers. In our first conversion, we will need a molar mass of Bi2O3. We find the molar mass of bismuth, 208.98. Let's call that 209 grams. If bismuth is 209, there are 2 of them, so times 2, plus 16 times 3 for the oxygen. I'm finding 466 as the molar mass of our compound, bismuth 3 oxide. My first conversion places 1 mole of the compound over its molar mass, 466. In the heart of our problem, we want over given. The target is bismuth. Its coefficient is a 2. 2 moles of Bi set over the coefficient in front of Bi2O3, which is a 1. A 2-to-1 stoichiometric ratio. We want the number of atoms. That's a counting unit. We use Avogadro. We know there's 6.02 times 10 to the 23rd atoms of bismuth in every 1 mole of bismuth. We will hit for this starting with 195. I'll divide by 466 times 2 times Avogadro, 6.02 E23. I find 5.04 times 10 to the 23rd atoms of bismuth. In our next parentheses, 3-stepper, we'll start with 129 grams of zinc. So we'll need a molar mass of zinc in our first equation. Zinc is a molar mass of 65.4. I'll place that, 65.4 grams in every 1 mole. We want over given in our second step 2 moles of Bi for every 3 moles of zinc, a 2-to-3 stoichiometric ratio. We still have 6.02 times 10 to the 23rd atoms of bismuth in every 1 mole of bismuth in our third conversion. 129 divided by 65.4 times 2 divided by 3 times 6.02 E23. My calculator says 7.9 times 10 to the 23rd atoms of bismuth. Comparing our two numbers, the first answer is the smaller of our two. I'm labeling that as my maximum yield. The maximum yield comes from the limiting reagent. I will label the bismuth 3 oxide as the limiting reagent, and therefore the zinc must be in excess amounts. Starting with the limiting, we target the excess reagent for part C. Knowing that, we'll have to end it in a mole unit. We'll begin by writing our limiting reagent, 195 grams of Bi2O3. We want the excess reagent as our target. I like to go as far as the grams of zinc so I can subtract like units. Once I know that mass that's been wasted, I can convert it into a mole. We need to subtract like units, so I'm going to do all 3 steps and get to grams of Zn. In our first conversion, Bi2O3 has a molar mass of 466 grams. I borrowed that from the problem above. We need a stoichiometric ratio of want over given. We want the zinc, it's the excess reagent. From the bismuth oxide, it's the limiting. We have a 3:1 stoichiometric ratio. We'll use the molar mass of zinc, 65.4 grams of zinc in every 1 mole of zinc, so that we can get a gram unit for our answer. 195 divided by 466 times 3 times 65.4, I find 82.1 grams of zinc. Remember, we started with 129 grams, our initial amount of zinc. Along the way, we used the 82.1. I'll take the 129, the initial mass, and subtract 82.1, and I find 46.9 grams of zinc were in excess amounts wasted. Now, if this were asked to report in a gram, we'd be done, but I notice it's not. It's asking to convert to a mole. So we'll just quickly do a mole map problem. 46.9 grams of zinc. We'll use the molar mass of zinc, which is 65.4, and we'll report our answer in a mole. So on my calculator, I still have 46.9. I'll just simply divide by 65.4, and I come up with 0.717 moles of zinc in excess amounts. So not only have I reported it